Last but not the least, Dr. Sarosh Hashmat Lodi, Vice Chancellor, NED University of Engineering and Technology, Patron-in-Chief TECH-IEM 2023, and our chief guest for today. Yours are also requested to join us. A huge round of applause for all our dignitaries. To formally begin with the conference, Dr. Sarosh Hashmat Lodi, Vice Chancellor, NED University of Engineering and Technology, Patron-in-Chief of TECH-IEM 2023, our chief guest for today, Engineer Suhail Bashir Shah Saab, Chairman IIP Karachi Center, our guest of honor for today, Dr. Naveed Anwar, CEO, CSI Bangkok, and a Senior Advisor, Asian Institute of Technology, our keynote speaker and guest of honor today, Dr. Muhammad Tufail Jokio, Pro Vice Chancellor, NED University of Engineering and Technology, Professor Dr. Asadur Rahman Khan, Conference Chair, TECH-IEM 2023 today, and Dean Faculty of Civil and Petroleum Engineering, and Professor Dr. Abdul Jabbar Sanghi, Chairman, Department of Civil Engineering, and Dr. Farooq Arif, Department Co-Chair, Civil Engineering, Department of Civil Engineering, Director, NED University Virtual Reality Center, and focal person for today's conference, respected faculty members, participants, dear students, and all the guests. A very good afternoon and a very warm welcome. I am Samra Masood, and on behalf of the Department of Civil Engineering, NED University of Engineering and Technology, I welcome you all to this inaugural session of Technology-Enabled Civil Infrastructure Engineering and a Management Conference, TECH-IEM 2023. It's organized by the Department of Civil Engineering, NED University, Karachi, in collaboration with Virtual Reality Center and Neurocomputation Lab, supported by the Institution of Engineers of Pakistan. Our main sponsor and funding agency for today's CPEC Academic Research and Development Unit, CARDU of Higher Education Commission of Pakistan. Our industry sponsors include AI Engineers and Opal Group. The TECH-IEM conference aims to exchange ideas and experiences of participants, including specialists, international national experts, researchers, and academicians related to sustainable development, aiming to promote a more sustainable future and foster collaborations amongst them. This will not only enable relevant stakeholders mutually engage for solutions to problems related to implementation of civil engineering projects in general, but would also support CPEC long-term plan, particularly with overall infrastructure development. To start with the proceedings of the conference, I request Dr. Fawad Masood to please come to the rostrum and recite a few verses from the Holy Quran. Sir, please.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم لو أنزلنا هذا القرآن على جبل لرأيته خاشعا متصدعا من خشية الله وتلك الأمثال نضربها للناس لعلهم يتفكرون هو الله الذي لا إله إلا هو عالم الغيب والشهادة هو الرحمن الرحيم هو الله الذي لا إله إلا هو الملك القدوس السلام المؤمن المهيمن العزيز الجبار المتكبر سبحان الله سبحان الله عما يشركون هو الله الخالق البارئ المصور له الأسماء الحسنى يسبح له ما في السماوات والأرض وهو العزيز الحكيم صدق الله العظيم. Now the English translation. In the name of Allah, the most beneficent, the most merciful. Had we sent down this Quran upon a mountain, you would have certainly seen it humbled and torn apart in awe of Allah. We set forth such comparisons for people, so perhaps they may reflect. He is Allah, there is no God worthy of worship except Him, knower of the unseen and seen. He is the most compassionate, most merciful. He is Allah, there is no God except Him, the King, the most holy, the all-perfect, the source of serenity, the watcher of all, the Almighty, the supreme in might, the majestic. Glorified is Allah, far above what they associate with Him in worship. He is Allah, the Creator, the Inventor, the Shaper. He alone has the most beautiful names. Whatever is in the heavens and the earth constantly glorifies Him, and He is the Almighty, All-Wise. Now the Urdu translation. शुरू अल्लाह के नाम से जो बड़ा मेहरबान और नहायत रहम वाला है. अगर हम नाजिल करते ये कुरान किसी पहाड़ पर तो तुम ज़रूर देखते इसको कि दबा जाता है, फटा पड़ता है अल्लाह के खौफ से. और ये मिसालें बयान करते हैं हम लोगों के लिए ताकि वो गौर व फिक्र करें. वो अल्लाह वही है कि नहीं माबूद सिवाय जिसके, जानने वाला पोशीदा और जाहिर का. वो है बहुत मेहरबान नहायत रहम वाला. वही अल्लाह वही है कि नहीं कोई माबूद सिवाय जिसके, बादशाह हकीकी, मुक़द्दस, सलामती वाला, अमन देने वाला, निगहबान, गालिब, ज़बरदस्त बड़ाई वाला. पाक है अल्लाह उससे जो शिर्क करते हैं. ये वो अल्लाह है खालिक, ईजाद करने वाला, सूरतें बनाने वाला. उसके नाम हैं सब अच्छे, तस्बीह करती रहती है उसकी जो कुछ आसमानों में है और ज़मीन में है, और वो है गालिब हिकमत वाला. सदक़ल्लाहुल अज़ीम.
Jazakallah, Dr. Fawad, for such a beautiful recitation. Ladies and gentlemen, I would now like to request all of you to please rise for the national anthem. Thank you so much. Ladies and gentlemen, now I request Professor Dr. Asadur Rahman Khan, Dean Faculty of Civil and Petroleum Engineering and Conference Chair for today, to please come over and present his welcome address. Sir, please.
Bismillahirrahmanirrahim. Honorable Vice Chancellor Dr. Saroz Hashmat Lodi sir, Pro Vice Chancellor Professor Dr. Tufail Jokhio, Suhail Bashir sahab, Chairman IP Karachi Center, Naveed Anwar Sir from AIT Bangkok, and Parvez Sir from WaveTech, and faculty members and students, a very good afternoon and Assalamu alaikum. It's indeed my pleasure to welcome you all to this conference on the engineering and management of civil infrastructure, which is technology enabled. And just to brief about it, that this conference is basically part of an ongoing project that we are working at the Department of Civil Engineering with the collaboration of the Faculty of Electrical and Computer Engineering and also the Hong Kong Polytechnic University, which is for the duration of the 3 years, and we are in the second year, and this is the part of that particular project. As you can see from the title, which says it's the technology enabled civil infrastructure engineering and management. So right now with the advancement in the computer and in the technologies, the things are going very much multidisciplinary, interdisciplinary, and especially the management and all those type of parts, we cannot avoid having some work to do with the collaboration of the other departments and other faculties. So this is a result of basically a proposal that we submitted, and alhamdulillah we got it, because the proposal was very much aligned with the things that we are having. So now we are in the second year, and now we have this conference which is scheduled for 2 days. Today is the inaugural session. After the inaugural session, definitely we will have a plenary session and then a panel discussion followed by the dinner, which concludes the first day. And then from tomorrow morning we will have parallel technical sessions. We have almost more than 30 papers from international researchers and the national researchers. And we will be having parallel sessions going on, one in the Department of Civil Engineering and one in the Department of the Mechanical Engineering, in the lecture halls and the video conferencing centers. And definitely those who are participating will get benefit out of it, and we hope that it's not going to end here. Even if we complete the project, that will have the results which will take us to the next, basically next steps of having the things done by using the technologies that are available to us. So I hope that those who will participate will definitely benefit out of it, and it will take us to the next steps, inshallah. So with this I conclude my address and wish you all the best in the 2 days of the conference.
Thank you so much, sir, for your kind words. Moving further, this conference is a continuation of the effort by CARDU on the project of technology-enabled performance monitoring and virtual digitization of CPEC infrastructure for sustainable maintenance decision-making, funded by CPEC Collaborative Research Grant, CPEC CRG 178. To get to know a little about the insights of what CPEC is all about, let's have a look at an introductory video. Can we have the video played, please?
A data acquisition DAQ system has been autonomously developed for the real-time acquisition of data from bridges. The system comprises strain gauges, accelerometers and inclinometers, as well as sensors for monitoring acoustic emissions and humidity. To validate the data obtained through DAQ, a pilot test has been conducted, wherein sensors were deployed on a beam slab system to observe the results. The subsequent phase involves the mounting of sensors onto the bridge structure. Finite element modeling has been conducted to establish a correlation with the data from the sensors. Concrete bridge in the vicinity of NED University has been laser scanned and processed to generate a mesh. The 3D model has then been integrated into a VR visualization for further analysis. Research has been conducted to develop a crack detection model via a streamlined approach to detect, localize, and rate external cracks in concrete bridges. A model has been developed using Pix2Pix, a conditional generative adversarial network for image-to-image translation from a source crack image to a target segmentation mask of the detected crack. Progress is underway to calculate the length and width of the detected cracks.
Thank you so much for such an elaborative video. It is now my humble request to Dr. Sarosh Hashmat Lodi, Vice Chancellor, NED University of Engineering and Technology, Karachi, and Patron-in-Chief for today and our chief guest for this conference to please come over, sir, and shed some light on the conference highlights. A huge round of applause.
Bismillah ar-Rahman ar-Rahim. Respected Dr. Mohammed Tufail, Dr. Asad, Dr. Suhail Bashir Saab, my very dear friend Naveed Anwar Saab, my colleagues and dear students, Assalamu alaikum and a very good afternoon. It is fortunate that this country is lagging behind in technology. And the reason I say that it is fortunate, because this gives us a very huge room for us to embed technology into the wide gap that is unfortunately available. And I'm thankful to Naveed Anwar Saab, who has always been very supportive and who has been giving ideas to NED University, to me, to some of my colleagues, to move in the direction with the rest of the world is moving. So Naveed Saab, thank you very much. I know Naveed Saab has traveled all the way from Bangkok for this half an hour presentation. So you can imagine that the value that he gives to NED University, and I also acknowledge and try to reciprocate in any manner possible. But thank you very much for being here. Coming back to my discussion, you know, when I said we are lucky that there is a technological gap, it's just to wake up the young bright minds sitting at the back of the auditorium today, because this provides you a wonderful opportunity to see what are the things that could be done and what are the things that needs to be done and what are the things that we need to change in our curriculum, what are the things that we need to change in our the body of knowledge that we are giving it to you, what are the skills that needs to be embedded. The world is moving very, very fast in technology. And the pace is not linearly increasing; it is exponentially increasing. And if it's even if it's today, it's very difficult to fill the gap. Imagine another few years later, you're struggling to even understand how the technology, how to cope up with technology, let alone be able to take the benefits of the technology which is available. Only a couple of months ago, Dr. Tufail introduced me to ChatGPT, and I had no idea what ChatGPT was. And now, the way it is pushing us, and these all kind of bots and generative AI are pushing us, sky's the limit. I had sent a video to Dr. Farooq Arif. I was at COP28 last week, and there was a huge 3D printer. And I've sent him a video. I made a video myself just to give him an idea, because we need to get onto that technology as quickly as possible. So it's so good to see that Dr. Asad and his team has come up with the idea of this conference, but the conference must not end here. We must have very clear direction from this conference and from the research project which Dr. Asad has mentioned, how to take our future studies and research forward. I see that even though there is there's a big void to fill, but at the same time it's a huge opportunity for us to lead in these directions in the nation at least. I am pretty sure that not very far in the distant future, we should be teaching our graduates of programming 3D printers for buildings. And these 3D printers will not only print in concrete, they will be printing in substitute materials like wood or similar to wood, similar to glass. So, instead it's like a colored printer. A colored printer has several inks. The 3D printer will have several materials, a concrete or a cementitious material and a wooden kind of texture plus a transparent material, so that you can print windows and doors and walls and whatnot. So are we prepared? Are we really going in that direction? Do we really need to have civil engineering? Dr. Tufail Saab will be very happy to learn this statement, because I see a lot of mechatronics application. So who needs civil engineers if the robots are doing it? IoT is obviously another domain which I was exposed to a few years, I would say about 10, 12 years ago, when I had an opportunity to visit Singapore. And Singapore, because of the lack of space, has tall buildings underneath which the whole train system works. And they have put in real-time monitoring devices to see the creep and the settlement of the infrastructure. And they monitor it on a real time. And I'm talking about 15, 20 years ago, maybe not 20, but 15 years ago. So at least it is good that we have started thinking in those direction, even though when I was looking at the video, there was Junaid Bangali's advertisement was more than the work that we have done here. So, this is how we paint our, the city in such a beautiful manner. So, but anyway, I would like to wish all of you a very good luck and see that this is not a conference for the sake of conference. This should turn into something which is going to help and enable us to set the future direction of civil engineering and embedding other disciplines into the construction industry. Thank you very much.
Thank you so much, sir, for your kind words. Now, ladies and gentlemen, we also have a special message from Mr. Khan Mohammad Wazir, Science Counselor, Technical Affairs, Pakistan's Embassy in China. Let's give it a listen. Can we play it?
Honorable Chief Guest, Engineer Najib Harun, Chairman Pakistan Engineering Council, respectable Vice Chancellor in NED University of Engineering and Technology, academicians, friends, ladies and gentlemen, Assalamu alaikum and very good morning. It is indeed a matter of great honor to be part of today's opening ceremony of the conference on technology-enabled civil infrastructure engineering and management. I, on behalf of the Embassy of Pakistan in Beijing, congratulate and appreciate the organizer on hosting such a beautiful event. The conference has brought together leaders, experts, researchers from within Pakistan and from foreign countries to share their experiences and generate new ideas on expanding and promoting a more sustainable future and to foster collaboration among them. Dear friends, as the conference is being held with the support of CPEC Academic Research and Development Unit and is in the context of CPEC. So let me share with the participant about the Pakistan-China Science and Technology Cooperation. I have been dealing China-Pakistan Science Technology Cooperation for the last 13 years and have recently posted as a science counselor in the Pakistan Embassy, Beijing. Dear friends, China has made remarkable achievements in science and technology and is now a global leader in many areas of science and technology such as artificial intelligence, robotics and industrial automation, quantum computing, 5G technology, high-speed train technology, digital economy, smart cities, electric vehicle, drone technologies, biotechnology, STEM education, and green technologies. Ladies and gentlemen, Pakistan and China are pursuing active science and technology cooperation since 1976. Since then, over 500 projects of cooperation have been completed. A joint working group on China-Pakistan Science and Technology Cooperation under China-Pakistan Economic Corridor has been established in March 2020. More than 50 cooperation agreements (MOUs) stand signed among the S&T and R&D institutions of the two countries. Currently, 60 joint research projects are under implementation among the researchers of the two countries. The two sides are now focusing cooperation in areas like emerging technologies, advanced materials, renewable energy, synthetic biology and biomanufacturing, smart cities, S&T parks, minerals, agriculture, renewable resources, biodiversity and climate change, medical technologies, vaccine development, STEM education, promote innovation and entrepreneurship, skill development through technical and vocational training. The cooperation is carried out in the form of materials, renewable energy, synthetic biology and biomanufacturing, smart cities, S&T parks, minerals, agriculture, renewable resources, biodiversity and climate change, medical technologies, vaccine development, STEM education, promote innovation and entrepreneurship, skill development through technical and vocational training. The cooperation is carried out in the form like capacity building, infrastructure development, technology investment and transfer, conduct joint R&D in areas of common interest, developing institutional linkages among the academic and R&D institutions, extending support at regional and international STI forums. Ladies and gentlemen, some of the projects currently under implementation are: first, establishment of Joint Research Center on Earth Sciences at Quaid-e-Azam University, Islamabad. Second, establishment of China-Pakistan Belt and Road Joint Laboratory on Smart Disaster Prevention of Major Infrastructures. China Southeast University, Shenzhen University, Tianjin Fire Research Institute, Hefei Institute of Public Safety of the Tsinghua University from China, while NED University Karachi, BUTM's Quetta, UIT Lahore, UIT Peshawar, and NUST are partnered institutions of this joint laboratory from Pakistan side. Third, China South Asia Technology Transfer Center, Sub-Center Pakistan, has been established recently. Fourth, training and capacity building of policymakers and decision makers on STI ecosystem and science and technology park are under the MOU recently signed between Special Technology Zone Authority and the Great Wall Enterprise Institute of China. Fifth, cooperation on STEM education between Pakistan Science Foundation and the Chinese Association of Science and Technology for teacher trainings, student exchanges, and resources sharing. Sixth, establishment of an international think tank for science and technology and economic development. 7. Promoting innovation and entrepreneurship through China-Pakistan Double-Hundred Enterprises Promotion Project. Ladies and gentlemen, under the direction and guidance of the Ministry of Science and Technology Pakistan and His Excellency Khalil Hashmi, Pakistan Ambassador to China, The S&T wing of the Embassy of Pakistan in Beijing is available for all possible support in linking Pakistani institution and researcher with their Chinese counterparts. In the end, I thank you all and wish the conference all success. Long live China-Pakistan friendship.
I almost believe that we are live with him. So nice of him to send his greetings and well wishes. Ladies and gentlemen, Dr. Naveed Anwar, CEO CSI Bangkok and Senior Advisor, Asian Institute of Technology Bangkok, is our learned keynote speaker for today and also our guest of honor. He has privileged us by traveling all the way from Thailand. Dr. Naveed Anwar is a structural engineer and academician, currently the CEO of CSI Bangkok, and also affiliated with AIT Bangkok. In over 40 years of professional engagement, Dr. Anwar has had the unique opportunity to work in vast spectrum of civil and structural engineering knowledge cycle in teaching of graduate programs, postgraduate research supervision, publications, development of software tools, and technologies for application, training, and capacity building of professional engineers, and direct engagement in hundreds of international projects, all of which have fed back into teaching, research, and development. All of this is done in a truly international setting, spanning over 20 countries under the umbrella of one of the top international universities and in collaboration with one of the world's leading structural engineering software development companies. Ladies and gentlemen, let me invite Dr. Naveed Anwar to present his keynote address on application of emerging technologies in bridge lifestyle. A huge round of applause. Welcome, sir. It's working?
Okay. Assalamu alaikum. Thank you so much for that introduction. And first of all, yes. And thank you so much for NED to inviting me. It's very close to my heart, and I was telling the Honorable Vice Chancellor, as a close friend, I remember him visiting our AIT office a few times, long time ago, and we used to have chat in my office and have coffee, and I think now it's been several years, and that collaboration and that friendship has grown a lot. And once I got the call from Dr. Sanghi, I really, was thrilled, and I wanted to come here and to share something about this topic, because for two reasons. One is that this is working? Or can somebody can it work? Okay. Sorry, please. Oh. So, no, this is common technology, no matter, and this happens not only here. I have the privilege of, giving talks in many countries in many highly advanced environment, and this still continues to happen. So I always say that we are gone far ahead in many technologies, except how to manage the LCDs and the computers displays. So anyway, so talking about ChatGPT, I was lucky enough to get involved with ChatGPT right immediately after its launch last year in December, and I have been actively sort of watching it. In fact, we are now using it as one of our tool and building our application on top of the OpenAI's platform. So when I was coming here for this talk, obviously my best assistant and my best advisor right now is ChatGPT. So I asked ChatGPT that I'm going to present a conference on this topic. What do you think? And can you give me, and it's a CPAC project, and I gave all the background. And I said, can you give me a starting picture to show? And this is the picture that was generated by ChatGPT for this event, for this conference, and for this particular topic. So anyway, so this is, as you can see, first it generated the bridges, and I said, no, it's a mountainous area. And it knew about the CPAC project quite a bit. So it added actually China-Pakistan flag, but I removed that later. Anyway, so let me first start with the bridge project itself. Bridge project, in my view, being a structural engineer, when I was just starting, like more than 40 years ago, I thought this is one project that I would like to do, because this is purely structural engineers' project. It is not architects' project. Buildings and other places, I thought at that time, because I was working with some architects in Lahore, some renowned architects, Nair Dada and all of those people, and I thought that I was just supporting their vision. I didn't have the ability to create something of my own, and I thought bridge would be one where structural engineers can do that. Unfortunately, it's no longer true now. Bridge projects have become far too complex, and aesthetics, environmental considerations, many other things, technologies are gradually taking it away from structural engineering, as I will discuss a little bit. And it's a sad thing to see that structural engineers haven't really kept up, or civil engineers haven't really kept up pace with keeping this interesting, infrastructure entity in their hand. So if you look at the bridge project, it's actually very complex. If you look at the mind map of the bridge project and you look around and you see it has different structural form, different materials, different components, stakeholders, many uses, a lot of analysis tools, and then construction methods and so on. And if you expand this further, you will see that each one has its own further categorization. I could go on forever expanding this mind map. It will fill all the screens that we have, and it will not end, because the project and its details are so complex, so intricate, so in-depth, that we can continue exploring that. And that means that the bridge project has a lot of things that we can do, and a lot of areas where we can use our knowledge. But if you look at the emerging technologies, it actually covers everything. There are emerging technologies or technologies applied in every aspect of this one. If I just take analysis and expand into nonlinear analysis and moving load analysis and construction sequence analysis, and I can go on and on, there are technologies in that. So every aspect has in-depth technology application. Of course, we can't cover all of that because it requires several presentations by itself. So let's just focus on one part, which is the life cycle. That means, like somebody said just now, from the cradle to grave kind of a concept. Although now the grave is not an acceptable end of life of a structure. We are not supposed to end a structure and demolish it. We are required to find a way so that it doesn't really have an end. But anyway, for the bridge life cycle, if you see, this life cycle cannot be completed without people involved. And so we have the stakeholders. Stakeholders mean people who will work on various aspects, various phases of the bridge life cycle. And then, of course, we have the emerging technologies coming in. And these emerging technologies will connect with the bridge project itself, but also with the stakeholders, because it can't be done without the engagement of the people who will do it. So technology must connect with the bridge itself, and also the stakeholders, to enable this whole system to work. So now, in this particular context, I was told it's about the CPAC. So I looked it up, and I said that there's already an application of a lot of advanced technologies going on here. It's a strategically important structure, an important project, and we have seen some mention of that before. So with that context, there are certain special things that a bridge life cycle would look like. So bridge life cycle, it has phases in it, it has sub-phases, it has a lot of things happening, and of course, it requires technologies in different form or the other. So let's look at the bridge life cycle itself for a while. So this is a very simplistic life cycle, starting with planning, approving, funding, design, construction, operation, maintenance, and traditionally demolished. But of course, we will see that that's not an option, but this is a traditional, simplistic life cycle. But the real life cycle of a complex bridge project in an environment like this one would be more detailed. And if you look at that, in the planning phase, there'll be many things that we have to do. In the design phase, there'll be a lot of engineering involved, a lot of work to be done. Then in the approval and funding, this is a whole process of getting all the approvals, land acquisition, because it's an infrastructure project. It's far more complex than a building project. Then we have the construction phase, all of these things about the site preparation and its remote areas, and then the superstructure, substructure, foundation, they all have a lot of difficulty, especially in substructures. In fact, one of the most difficult part in many bridges is actually the substructure. Elevating the bridge substructure to receive the superstructure, which has to follow a certain profile given by the highway design engineers. And so substructure becomes a critical selection or development. And then, of course, operate and maintenance, because these are public infrastructure projects, so they have to be operated and maintained over time, and we have to have operators, people who run these facilities. Then we have the rehabilitation phase. We have to address the wear and tear, upgradation, modification, and so on. And we have seen now one of the projects that we are doing here in Karachi is about the structural health monitoring part of that. And then we have demolition, replacement phase, or repurposement. People are saying that we should now repurpose the bridges. If it has become old, then maybe make it only for light traffic or convert it into a pedestrian and so on. So repurpose the bridges. And then we have the environmental considerations, and then obviously the technology integration that we are going to talk about. Safety, sustainability, life cycle assessment that we heard about. All of that are now part of this broad life cycle of the bridge. Now, second important part is stakeholders. So people who actually sit down and get involved and do this over a long time. Most of the time, civil engineers or designers especially are taught to think about the design and construction phase. They do not sort of focus on 70, 80, 100 years after the design is finished and the construction is finished. That is the real time that we have to think about for a project, or even buildings or bridges, that what happens during that time, because that's where your design decisions will impact. So those stakeholders, many of them come into play before the bridge starts and many afterwards. So we will have stakeholders from governments, agencies, private sector. This is the traditional ones, including government agencies, regulatory bodies, and so on. So I don't need to list these, but broadly we have the stakeholders from these two groups. For this particular context of CPAC, we will also have the Chinese government, the Pakistan government, the HSE, and we will have the other bodies, and we have so many more things because it's more complex than a traditional project done by NHA alone or any local department alone because of the international context that we have. And NGOs and civil organizations and civil societies will also get involved because the project is passing through areas that are sort of sensitive politically and so on. So it's far bigger. Stakeholder engagement is far larger than a typical project, let's say, over a bridge or in the city. So let's look at now the emerging technologies that will impact this one. I think many of you are already aware of these technologies, but let's put them in the context of the bridge phases. So first of all, what should be the role of a technology? When we adopt a technology, why do we need to bring technology into a process? A lot of people say, oh, it's already doing. Why do you need to bring the technology? We have been doing this for hundreds of years or 100 years, 50 years. Why do we need to bring in technology? It's already happening. The purpose of technology, to me, is three sort of areas. The first one is to make the process easier and efficient. That's, of course, the easiest way to adapt technology. Second one is to create a better system or better solution. And the third one is the more important one, is to address problems that could not be addressed otherwise. That means these are the things which areas that didn't exist because of many other aspects. So we can now address that we could not do. It's not just automation of what we used to do. We can do more than we used to do. That's where the technology comes in. So if you look at the technologies broadly, they can be categorized into engineering and construction technologies, sensor, IoT, and monitoring technologies, and surveying and visualization technologies. And then most of them we are aware of. They have been mentioned in the morning. So now we will see how they relate to our bridge life cycle and see some examples later. So the biggest impact is on IT and AI and data analytics, which are new and which are rapidly taking over most of the things that we do. And on one part of the world, people think that, okay, these technologies, this AI is going way too fast. You see, just imagine a few people sitting in OpenAI office completely changed the world without asking the universities, do you want your graduates to learn ChatGPT? Do you want them to learn AI? They just went ahead, invented something, and overnight everything changed. So such technologies will be developed and will be continued to be developed, which we have no control over, and we will have to respond to them and not be able to sort of have any say in their development. I think we are all familiar that the EU and other governments are now getting together to create some kind of rule book for these technologies to be developed, because the companies develop them fast, and their people do not have time to react, people do not have time to learn, people do not have time to adjust, and they just keep on moving. So there's a gap is increasing between the people who have them and people who haven't adopted them. So that's why IT, as well as AI and DA, these are the big ones that we should be concerned about. The previous ones are slow to catch, like IoT. Takes time. It's hardware-based. It's different. So let's look at the application of these emerging technologies. By the way, all the images generated by ChatGPT for this image, I just gave the topic and worked with it and then got the image. So now we're looking at 3 items that we want to interrelate because they are connected. The first one is the life cycle and technologies. Second one is stakeholders and life cycle, and then stakeholders and technologies, because we started that Venn diagram in which we have these 3. So we have to connect them together and see what is relevant for what. What are the phases of bridge life cycle relevant to stakeholders, and which stakeholder to which one? And so we do the mapping. So we understand who needs to adopt what, and what technology is suitable for what kind of work. So let's look at this part now. So technologies and life cycle phases, first one, so we can see there that for concept design, we have VR, data analytics, for feasibility analysis, and for environmental impact analysis, we have GIS, drone-based surveying, and so on. For design and engineering, you have BIM, which I will talk a lot about, and then we have 3D modeling, and so on. And funding, we have blockchain, AI-driven predictive budgeting tools. So we have technologies for almost every part of the work that will be done in the bridge. We have procurement, e-procurement system, smart contracts using blockchain once again. And then we have construction, 3D printing. The Vice Chancellor mentioned about that. It's definitely something that is very relevant, and it's going to expand. QA using sensors and IoT, commissioning, operation, inspection, monitoring, once again, drones and sensors and IoT, and rehab, and so on. So we can see here that there is room for technologies in every aspect, every phase of the bridge life cycle. And you can draw this mind map again to see which of the phase of the life cycle will be connected to which technology very quickly. So we can quickly see that, okay, this particular phase of the life cycle has these technologies related to that which we can use. So it's a quick mapping that we can use kind of as a quick guide. We can also create this mapping between the two. So it will be very clear that, okay, which, on one side we have all the technologies, on the other side we have all of these phases of the bridge life cycle. So the marks here show the relevance. So you can see which technology is most relevant for which phases, and which of the phase uses which technologies and how many technologies they use. So we can create such mapping to clearly understand what is the relevance of the various technologies to various life cycle phases. So it's easy for us to pick the technologies, understand them, and apply them. Similarly, we could create a map between bridge life cycle and stakeholders. Which stakeholder is involved in which life cycle step? So once again, mind map can be created for this relationship, and we can see, okay, who will be involved in doing which part of the bridge. And this gives us a clear picture of the engagement of people in the phase over the lifetime of the bridge. And once again, we can create a mapping, which stakeholder will be involved in which phase of the book, and then we can we'll clearly see that, okay, governments and others, they have to be involved in everything. And then other designers in this one, and project management teams and all of that stuff. So we can quickly create kind of a visual correlation between the stakeholders engagement and the bridge life cycle. So then we can say, okay, who has to do what? It's like a responsibility matrix, that who has to do what in a bridge over time. Then stakeholders and life cycle. So, we can continue to do this analysis and continue to try to understand how these things relate to each other. And the reason for doing this one is to develop a very clear understanding of these three important aspects: life cycle steps, the stakeholders, and the technologies. And similarly, we can have stakeholders and technologies that, now this is very important. This slide shows us that which agency needs to learn or needs to be aware of which technology, because this will lead to the next step of the capacity building, because technologies cannot be adopted without the stakeholders being engaged, trained, and given the tools, and especially given the developing the capabilities. So this will help to identify the training needs or need assessment for capacity building and for their engagement in various technologies. So once again, this map can quickly tell us, okay, which part has to go where. And then based on that, the planning can be done, and based on this one, we can see how we are going to, which the construction companies need to have those tools, and then so on. And they have to be trained in these areas. So this can create us kind of a roadmap for the stakeholders and technology engagement. And that brings us to that part that I mentioned is most important in this one. We have seen, every one of us has seen that funding comes, we buy equipment, we put it in the labs, and nobody is using them. I'm not talking about NED, I'm talking about many places that we have visited. And because of the lack of training, because the lack of capability, lack of capacity building, because we have obtained the tools, but we haven't trained the people to apply them or to use them. So that's one of the I would say, key reasons for failure of adoption of new technologies is the capacity and capability. So that's why this needs to be done, targeted training programs, and that's where the universities come in. The academic institutions, the training institutions can come in to develop programs in those areas and target particular stakeholders and approach them that, okay, you need this one, and we have this program that we can offer to you. In fact, AIT is very, very good in this. We have AIT Extension, one of our departments, that just exactly that. They develop training programs, especially to the needs of the public officials. And they have trained roughly 48,000 people in the last few years. Government officials from Bangladesh, from Pakistan, with a big project going on with Punjab, with Sindh, with ADB funded, World Bank funded projects. In fact, there's a capacity building component in every major project, and so on. So I think this is an area where the academic institutions and training agencies can get involved. Then collaboration, because obviously project like this people have to work together over a long time, and the data has to be transferred. So collaboration using cloud tools is very, very essential. Once again, a technology, cloud-based, collaborative work is absolutely essential now. We are all using it sometimes without knowing that this cloud-based collaborative tools that we have. Whenever we use WhatsApp, whenever we use anything, it's all happening behind the scenes. So we can use this as an explicit way to collaborate over the bridge life cycle, especially in terms of the technology adoption. One more item that I want to discuss is the life of a structure. We are taught, for whatever reason, somehow that the life of a structure is 50 years. I don't know where this number came from. Or the bridge is 70 or 75 years. And then the question is, what will you do if you want to design a building for 75 years? What step would you take? If you go to a designer, structural engineer, say, a client comes to a designer, say, I would like to design a house or a building that lasts 100 years. Structural engineers, do they have the ability or the decision-making to say, okay, I have designed this, and now the life is 100 years, and I can certify it's going to be 100 years? Because we haven't explicitly assigned life of a structure to the actions that we take. So this is just a rough guide on this question. So if this is the basic design life, this can be extended by using better maintenance. This can be extended by using improved durability. This can be extended by increased safety factors. This can be extended by repair, restoration, and refurbish, by retrofit and repurpose, and explicit design for extended life, which is a whole field by itself. That means you change the whole, expected wind return periods and seismic return periods and cover and this and that. So you explicitly design for long life structures. Because we were once asked by a client in Bangkok that they would like their buildings to be designed for 200 years. And that was an unusual request. So we had to sort of really prove that, okay, this different building is different from a regular building because we have taken these steps. So another very important aspect of the technology application is the digital twin concept, or the digital skin concept. That is that you have a real thing and then you have a twin which is digital, and you maintain the digital as if it was real. So this twin thing has to be established, and this is the big thing right now in the infrastructure construction industry, and I know that NED and other colleagues are working on it also. So let's look at the digital twin as a way to adopt bridge technologies. Okay. So digital twin has the ability for replication, data integration, simulation, lifecycle management, predictive analysis, and operational efficiency. So these are some of the benefits that can come from creating a digital twin of a project. And application is in design phase, in construction phase, in maintenance phase, emergency response, and end of life. So everywhere the digital twin will be used. So now it's easier said than done, because digital twin, to create that, you need to have data. You need to have information, very detailed one, from everyone involved. And this is something that the whole industry is struggling. And not only in Pakistan, in many advanced countries as well. So these are some of the important concepts behind that. The first one is the IDD, the Integrated Digital Delivery System. Singapore government is actively working on this. We are part of this project for a few years, that everything must be delivered digitally. There is no paper to be delivered. So it has to be integrated across disciplines and has to be delivered digitally. So that's one. And then digital skins and digital twins have to be created for a project. And for that, BIM for buildings and BRIM for bridges, and IFC as a underlying sort of standard are the key components on how to make digital skins or digital twins possible. And another two important part of that is parametric modeling and generative design. So by using parametric modeling and generative design, we can leverage the next three above to do the one on the top. So at the bottom is going to be parametric modeling and generative design. So I'm going to spend a few minutes on those two topics so we can see how that works. So the most difficult part these days, and most valuable part these days, a valuable commodity these days, is information. We all know that. We create more information every day than it was created in the entire human history in the last century before that. So there's an enormous amount of information being created, which is distributed as images, videos, drawings, models on the internet. This is everywhere, in every format. So information is highly complex in terms of the type of information and its distribution where it is. So how do you put it together if you want to create a digital skin? And that's where the idea of the BIM comes in, or BRIM comes in, that you attach this information to a physical entity in the project so that everything is directly connected. If a picture is taken, a video is taken, a newspaper publishes an article about that, you attach it to an entity inside the model. So that means the physical model needs to be present so we can attach the information to it. And that's where the BIM comes in. So BIM has advanced a lot over the years in two directions. I think many of you are familiar with that. One is the dimensions are increasing from 7D to 10D now, and the level of detail is increasing. So that means the amount of information going into BIM models is becoming highly, highly complex. From 2D drawings, which is what we all used to see, to having a 10-dimensional information model is really highly complex. And not only that, the level of detail is also 10 steps. So that means you combine level of detail with the dimensions, you get really enormous amount of data that you can then manipulate to do almost everything. But the question is, how do you do this? Because it's not going to be easy. So parametric modeling and design is the first step towards that especially for bridges, the bridge must be defined parametrically. Things cannot be just a line or an entity that we use to draw. In an AutoCAD, we draw a line or an area or a polygon. It cannot exist because that has no meaning. So it must be parametrically object-based. So that's the first thing. So for example, if you want to define a bridge pier, then you define dimensions, and then it is generated from the dimension. You never actually draw a bridge pier. There's no drafting now included. It is parametrically defined. So if you have the parametric model, then from that you can generate a 3D model very quickly because it's parametrically defined. You can generate the mesh, and then you can generate the rebars inside also using the same parametric information. These images are, by the way, from a program called CSI Bridge ET that we have just almost developed. We have been working on it for many years. So this is a kind of an ET stands for emerging technologies. So it's a bridge software using emerging technologies as the base. So you can see here that everything is completely parametrically defined, and reinforcement is placed in the object before even you design it. So it comes as part of the object as a component. So reinforcement is there. When you bring the column, it comes with reinforcement. You don't wait for the design to happen. So the cost estimates, many things can be done right away. You can immediately use it. Then you can create many types of these components, parametric components, and then assemble them together to create a bridge bent, for example, and assemble them together to create the whole bridge. So the entire bridge basically becomes a fully parametric model that can be changed very, very quickly. You make one change and it spreads everywhere. And this is not a new concept. People have been using it. But to apply it systematically is what we are looking at. Then, if you do that properly, then you can complete the entire cycle. You can start with a parametric model. You can create a finite element mesh because it's a well-defined entity, automatically do the analysis, calculate the bending moments and so on, calculate the capacity of the cross-section of the column, for example, or piles, and update the reinforcement, calculate the quantities because everything is already there, and then make the rebar schedule. All in one go because we defined it parametrically. You don't need to draw anything after that. It's all automatically connected because it's parametrically generated. And that's the foundation of good BIM, that it should be based on parametric modeling. So if you have a parametric definition, it should be communicatable to other programs that also use parametric modeling approach. So if CSI Bridge ET can then communicate that data to an IFC model and then to a Revit model. So same object can be defined here, brought to Revit, changed in Revit, brought back to CSI Bridge, because parameters are the same and they all work on the same parametric definition and logic. So they can be interconnected, interoperated without loss of information. So this gives us the ability to work on a common model where then everyone can work. Construction people can use the same model and so on. This is one of the projects that we did in Sri Lanka, combining the parametric model with the 3D drone model that we created of the whole 5-kilometer place, created a 3D drone imaging and converted that into a 3D model and then placed the bridge on top of that. So I think you have all seen this one here because we have a very advanced VR lab here. So it's nothing new, but let me just tell you that because of the parametric definition, then you can do all of that stuff much easier than using, and you can see the reinforcement cages, and it's also coming from the same parametric model that you can just export them into this environment. And you can also have augmented reality where you can place this onto the real bridges and start comparing the response with the bridge, because now we can overlay the two models because they are parametrically defined and they are identifiable, connectable with each other. Now let me go to the last couple of slides, which is parametric generative design. So because now we have parametric system, we can manipulate the parameters any way that we want using whatever logic we have. So we can do a generative design of the whole components and the bridge, just like the generative AI that we see. So this is not a new idea. Architects have been using it. Zaha Hadid used that long time ago in this design of this beautiful building, structurally well-balanced, parametrically defined, and generative design was used to find the best form, both architecturally and structurally. So this is one of the good examples of using generative design, and other examples of generative design or have also been done by architects. Somehow they're always the first to adopt. BIM, architects did it first, before us. Generative design, they adopted it before us. And in fact, I think structural engineers need to do it. One more bus that we did not catch on time is the sustainability. That also belonged to civil engineering. We were too late. Anyway, so you know this bridge. I think everybody knows about this bridge. So somebody thought that why don't I use a generative logic to regenerate this bridge purely from the stress flow perspective and find a structure that will transfer the stress in the best way. And they come up with this design. Of course, it's not realistic, but the point is this generative design has no controls because it's not parametric. What we need is a parametric generative design that does not violate the physics of the object. And for that, we have this one. For example, it's a very small example. You can use generative design to go over all the parameters, possible parameter values, and find the best one that you're looking for in terms of aesthetics or quantities or stresses or whatever. So you can continue to do that. It's just for the demonstration purpose. But you can use this concept to arrive at the best solution by rapidly going through the parametric variations within a certain range. And even the rebars can be parametrically optimized in the same way. You can find the best reinforcement, calculate the capacity, keep on doing it until you find the best cage and best form to go together with the parametric. So this can all be done because the things are parametric and they're not independently defined from the object. So these are all part of the CSI Bridge software that I mentioned. And last couple of steps. So we thought everybody's talking about generative, you give the prompt to the AI and it gives you the response. Why can't we have a prompt-based software that you give a prompt and it does something for you? So we experiment. This is not really, it's a kind of a beta thing, but I wanted to share with you. No one outside our office has seen it, by the way. This is the first time that we are showing it. So this is a prompt. Create a curved bridge with 4 spans of 50 meters. And because of the parametric nature, the program understands what is span, what is curve, what is this, and it just goes on and generates that bridge quickly. Second prompt, generate a bridge of this spans, and then you enter that prompt and the model is created very quickly because it's defined parametrically. We can also go on to say, okay, I would like a straight bridge with 1 span 25 meters and span number 2 40 meters, and also run an analysis and design on it. So you get this prompt, go and have coffee, and by that time you come back, the program has already generated the entire design and also generated the reinforcement and quantities and all of that. So this is all something that we are looking towards because we define things parametrically. So I would say that future trends and developments will integrate technologies, life cycle phases, sustainability, stakeholders, and public interest, and AI will play an important role. So we must all get on board with this thing. Otherwise, like the Vice Chancellor mentioned, we will be left even outside this cycle. But we have a great opportunity at this time because these tools are available to anyone, to everyone. It's a level field in many ways. Anyone can access the things that we talked about. So it's a matter of, I think you know very well that in one country, as soon as this AI chatbot came in, immediately the people start to write a new CV and call themselves prompt engineers. A completely new job title was created next week after the launch of that, and we know which country we are talking about. And people started applying to jobs saying, I'm a prompt engineer, I can work with ChatGPT. And they got high salaries because people needed them. People made a lot of money by just creating a new job title. So that's the opportunity that we have. Thank you so much.
Thank you, Dr. Naveed Anwar, for your keynote speech. It was very informative. The audience can ask the queries during the panel discussion later today. Now, let's not forget our sponsors for today, AI Engineers and Opal Group. We have Mr. Ghulam Mushtaba Sheikh, who has joined us, Regional Director of AI Engineers. He'll also be there tomorrow in our technical session at 9. So the Opal Group has a clip that we would like to share with you. Let's have a look at it. Please play. Okay, thank you. Now, ladies and gentlemen, continuing forward, our guest of honor today is Engineer Suhail Bashir Saab, Chairman IEP Karachi Center. I would like to invite Engineer Suhail Bashir, Chairman IEP Karachi Center. Sir, would you please come over and share your thoughts regarding this conference? Please welcome.
Bismillah ar-Rahman ar-Rahim. Respected Dr. Saroshesh Matludi, Vice Chancellor, NED University, Dr. Naveed Anwar from AIT, Dr. Asadur Rahman, Dr. Abdul Jabbar Sanghi Sahab, Dr. Tufail, and Dr. Farooq. Ladies and gentlemen, Assalamu alaikum. Well, to talk about something for which we heard a very knowledgeable talk from Dr. Naveed Anwar, it's really amazing. And what he shared with us, the way the things are moving, is really mind-boggling, and probably things will change, because we are myself being the engineer of 80s, when we were doing many things, and at that time the programmable calculators were there, and prior to us people were using slide rules, and those programmable calculators were something great. And I remember then lately, when you see there is a laboratory when the first computer IBM 34 came into NED, the size of the computer was that big that they need to break the walls to enter that computer in this university, and that was in not very far away, just we are talking of 1980-81. And now things have changed. We used to buy computer 486, 586, and there was a very expensive thing, and people used to be proud of it, that we have got such a such computer. Now it's all obsolete, and the way things are moving, the way the technology is moving, and the way people are adopting it, I have no words where we are moving. That's really. Dr. Saab mentioned regarding ChatGPT. I can share my experience that my staff, they suddenly started drafting letter very excellently. I said, what happened to them? And then I came to know that they are just giving instruction to ChatGPT. The letter is coming up. They are just modifying it. So all overnight, their skills have been changed. That's how the things are moving on. So I feel that this particular conference, especially Dr. Asad mentioned that they are doing this with regard to CPEC. So there are many aspects which need to be dealt upon, which need to be investigate, and then the results have to be shared in a way that we get some tangible results out of this whole project. That's the main, I suppose, priority. And Dr. Naveed guide us the way forward, where we are going. I was really happy to see that he's now part of CSI. So last year, Ashraf Habibullah was here, and we were having, beside whatever fun Ashraf creates, but he has done a lot of things, especially through CSI. Miracles have been done, and we are proud that he, being an NEDian, are now delivering a lot of things, and not only to NED, but to all the academic institutions wherever he goes. So really, and again, it's all technology. Started from Berkeley, just asking a professor that, can I use your software, and now how the things move, you can just imagine that sky is the limit. That's the way they are moving. So having said this, I really feel that this is a very important topic which we are discussing, and look forward to a very good conference. Tomorrow also, a lot of papers I have seen that they are there. So from the Institution of Engineers Pakistan, we are proud that we are part of this conference. I thank you all to making us a part. And as usual, almost every conference which is being arranged by NED or IEP, we are either you are our partner, we are your partners. That's the way we are moving on. And this year, the next year, 2024, we are going to have around 8 international conferences. Recently, we made a whole agenda of all the areas that are there, not only in civil engineering, mechanical, electrical, biomedical, and then infrastructure, and then also in the sustainable SDGs implementation. So our agenda is big. So hopefully our collaboration will work for the betterment of the country, for the whole world. I thank you all.
Thank you so much, sir. I would like to invite now Mr. Shahzeb Akhtar, Technical Director, WaveTech, our special guest of honor today and industrial partner, to please come over and share his remarks. A huge round of applause, please.
Thank you. Assalamu alaikum. Good afternoon to all. My name is Shahzeb Akhtar. I am the Technical Director of WaveTech. Before I begin, I would like to thank the Vice Chancellor, all chairmen, deans and faculty members for having me here today and giving WaveTech this honor. A few words about WaveTech now. WaveTech was established in 1986, so a long time ago. At that time, we started off by designing tracking systems for inclined orbit satellites. Back in the days, it was pretty advanced thing, but that is how we started our journey on the development of technological solutions. And ever since, we never stopped. Today, I can say that WaveTech is one of the leading technology company in Pakistan who is involved in the design and development of both hardware and software-based products and solutions. WaveTech has its presence through our own offices in 7 countries, located in Middle East, Europe, Africa, North and South America. Through these offices, we have a distributor network, and we sell our made in Pakistan products in all those continents. WaveTech involves in WaveTech design electronic queue management systems. Then we design special displays for financial markets, and then self-service kiosk and machines for banking and telecom sectors. So these are our main product lines. WaveTech's cash deposit machines are used by banks. Al-Falah Bank here used in all their branches, and many other banks as well. We are also the partners with NCR, so we have a lot of experience in this payment industry. So hopefully next year we will launch our own made in Pakistan ATM as well. In the telecom sector, we make self-service kiosks to issue SIM cards and facilitate payments, bill payments, etc. And our kiosks are being used by leading telecom companies worldwide, like Do Telecom of UAE, then Cable and Wireless, Airtel in Africa, in Seychelles. So in the queue management systems, we are number 2 in the whole world. So we make a lot of versions of it and sell it all over the world. Our customers are A-rated companies, like Emirates Airline has our queuing system installed in all over the world, in all their branches. Similarly, Dubai government used it in their EID offices, where they issue EID cards. Similarly, banks, Barclays, HSBC, and the list is on. So alhamdulillah. So we are also, all our WaveTech products meet the industry standards, and we have all the certifications, alhamdulillah, needed to sell in those regions. We are also 9001, 27001 certified, GDPR compliant. For the North America, now we are in the process of getting SOC 2 Type 2 compliance as well. So we are also the partner of Meta for WhatsApp. So we use WhatsApp and build solutions around it using their API, which Meta has given to us. So there are only few companies who have that status of getting that partnership with Meta. So we are also having that honor. Recently, WaveTech has started a EV division, a company with the name of EV Technologies. And our objective is to launch green solutions through that platform. Inshallah, next year early, we will launch a EV bike. That bike will not be a standard like imported bike, as we focus more on the R&D and self-reliance. So our objective is to make those parts here in Pakistan. So inshallah, our target is to achieve 80% parts here, even including the batteries, which are very difficult to do. So let's see we achieve that. NAD has always been the constant source for us for providing top-class brains and human resource to strengthen our hardware and software divisions. Thank you for that. And we congratulate all management and faculty for maintaining that high standard. Thank you. I'd like to end my speech. And once again, thank you all for having me here. Thank you, Jay.
Thank you so much, sir. Sir, yes, sir. Thank you for your kind words. Ladies and gentlemen, it's now time for the presentation of mementos. For that, I would like to request Dr. Sarosh Hashmat Lodi, Vice Chancellor, NAD University of Engineering Technology, Patron-in-Chief, TECH-IEM 2023, and our chief guest for today, and Professor Dr. Asadur Rahman Khan, Dean, Faculty of Civil and Petroleum Engineering, and Chair for TECH-IEM 23 for today. Please join us here for the presentation of mementos. So please come over. Can we have a round of applause? Okay. As a token of appreciation, first of all, I would like to invite Mr. Ghulam Mujtaba Sheikh, Regional Director, AI Engineers. Would you please come over and receive your memento, sir? Thank you, sir. Mr. Waqas Sheikh, Manager South, Opal Group. Can we have you here, sir? Thank you, sir. Mr. Shahzeb, Technical Director, WaveTech. Can we have you upstairs here, sir? Thank you, sir. Dr. Naveed Anwar, our keynote speaker and guest of honor for today. Thank you so much, sir. Engineer Suhail Bashir, Chairman IP Karachi Center. Sir, please come over. Thank you so much, sir. Sir, now you two have to stay back for a while. I would like to request Dr. Asadur Khan, sir, would you please present the memento to Dr. Sarosh Hashmant Lodi, our patron-in-chief and our chief guest for today. Yes, thank you so much, sir. Thank you. So this session is going to be followed by Asr break and high tea. After that, we'll have our plenary session that would commence at 5, if I'm not wrong. Right? Okay, 5:15, you can gather back here for the plenary session. After that, we'll have Maghrib prayer break, and then we'll have a panel discussion. And after that, you can join us for dinner as well. So this brings us to the end of the inaugural session. Before we move forward. Okay, we are not having the... Okay. So high tea is served in the fountain area outside. You can join us for high tea there. So we'll meet after the Asr prayers. Thank you so much and a very good evening.
CPAC CRG project. We have two speeches. First from Professor Dr. Asadur Rahman on topic overview of project concept and achievements. I would like to invite Dr. Asadur Rahman on stage and deliver his speech. Thank you.
The project that we are working on and what we have achieved up till now. But before I continue, I would like to thank Dr. Naveed Anwar for simplifying the things for me. What you have discussed, we have been doing those things, so I will not have to explain a lot of things about this. Thanks, Dr. Sir. Okay, so this is basically the project title that we are working on, which is Technology-Enabled Performance Monitoring and Virtual Digitization of CPAC Infrastructure for Sustainable Maintenance Decision Making. So I am the PI from the Pakistan side main, and from China, the Hong Kong Polytechnic University, we have the other PI. And this Professor Yi King Ni is also the chair of the ISHMI group, the institution. So. And this project was for the duration of 3 years. It started in January 22, and we are expecting to end it in December 25. And these are the co-PIs. So Dr. Saad Qazi, who is the Dean of Electrical and Computer Engineering, is one of the main co-PI. Then Dr. Farooq Arif, Dr. Shamsun Farid, and Dr. Hashim Raza. So that mix shows that we need to have interdisciplinary things, and we are working on it. To support us, definitely we have RAs from both the background, the civil engineering background, and the computer science, electronics, and software engineering background. As Dr. Naveed already mentioned, civil infrastructure is a living companion. It lives with us. We cannot just leave it alone. And we have to take care of it from birth to death, just like cradle to grave. But as Dr. Naveed mentioned, now we don't look for the graves. We look for the reshaping, refurbishing, and those type of things. And for definitely that, we have to look for the life cycle of the structure from the concept and the main and design detail stages and all those type of things that come over there. And during the lifetime, definitely, we have number of cases where we can have change in loading conditions, climate change, sustainability, and all those type of things that comes into the picture. And they have long life cycles, just like we initially thought of like 50 years, but it can go to 75 years, more than 100 years. That comes over there. And definitely due to these diverse uncertainties, to all the things starting from material properties, structural robustness and resistance, with all the natural, societal and economical influences, we have to work with those things. Then basically, as the emerging technology, AI is there to deal with all those types of diversities and complexities, and to give us and come up with the solutions, alternate solutions. And as we have just seen now, the generative AIs and all those type of things are there. So we thought that instead of doing some conventional thing, we have to look for some of the emerging technologies. Okay. Then the structural health monitoring is not a new term. It started, I think, way back in, early 90s or maybe even earlier before. And then they used to work with the wired collection data through the wired sort of sensors and all those type of things. But with the evolution, with the time and all the emerging technologies, now it has gone to the wireless collections and all those type of things. And the data that we collect from the structural health monitoring, definitely it's a big data. So you have to have the data analytics and all those type of things are coming over here. So you can see the integration of all the new emerging technologies in in the design and maintenance and all those type of things of the civil infrastructure, which initially was not thought of, but now it's a very rare thing. So we need to work together to come up with the solutions. So definitely we have to have data acquisition system, then we have to process the data, because with so much huge data, without processing, using it is not going to lead to anywhere. And definitely then we have to have health evolution subsystems. So using those wireless technologies, definitely it has become easier, maybe cost effective. You can apply or deploy the sensors and the other things from which we want to have the data. They can be collected. The need of wires is no more there, but definitely we have to be careful about all the collection of the data. So then basically that was the idea behind us, and we thought if we can do something to come up with a system that we can use for the decision making for the future maintenance and all those type of things. So we come up with this proposal, and that's the first paragraph is basically the objective. We want to develop a stable and robust system for sustainable maintenance decision making based on definitely the technology enabled performance monitoring and virtual digitalization of CPEC infrastructure initially, but definitely that can be extended very easily to the other infrastructure which is of importance. So this is what we proposed. First we have to collect the data, we have to do the analytical modeling, then also the visualization modeling to have a better understanding of what's happening, and then finally the decision modeling or the decision making. So the next figure basically summarizes the project. The first one is definitely a very huge task. We have to collect the data that can be sustainability data, the aging data, the deterioration, energy consumption, emissions, and all those things. Plus, then we have to have the IoT for the data collection that can be embedded sensors, load sensors, and all other types of sensors that we think that can be used. From the data, then we come to the analytical modeling using AI techniques, and just directly from the data, and also from the images that we can take from different types of sources. Then comes the visualization modeling, from where we can have the laser scan data for the bridges. We are focusing on the bridges right now, and then we can just go for the other things. And ultimately, we will be looking for the something which can give you the idea how to prepare for the next few years for the maintenance and all those type of things that we have. So that's just a very, very common figure to describe the things. If we are having a bridge, so these are different types of sensors that we can deploy, and they will be attached to the actual bridge or the actual structure, and from there those data can be collected, and we can have the data, receiving the data, and then we can process accordingly and come up with the things, and especially the modeling part. So first we will collect the data through sensors, and definitely we will have to deploy the sensors at different locations which are of importance. Then it will be used to perform analytical modeling with the help of AI techniques and numerical simulations. And this data will also be utilized for the life cycle assessment and analytical modeling. Once we have enough data, then we will go for the visualization in the virtual reality system. Also, we will be parallel doing the FEM modeling and those types of things. And then we will also have a digitized inventory of the whole infrastructure using LiDAR for the real-time scanning of the real-time structures. And then ultimately we will be going to the decision making taking into account the past decisions, what has been done before, and how to predict what is going to happen and how we are going to make the decisions for related to the maintenance and the other strategies. Okay? So what we expect is we will be able to give a system that is not only beneficial for the CPEC-related structures, but later on can be implemented on all other important infrastructures that we can have in Pakistan, definitely. But first we need to have a robust structure, and then it can be implemented to the other cases. So these things are some that we have already done, and the rest of things, if you see, almost all the main initial work required for the decision-making modeling has been carried out, and now we are in a phase of collecting the data on an real-time in infrastructure, which will be a bridge on the CPEC route, and then we will be finalizing the things and showing up the things. So I will just show you some pictures from the literature and from the things we worked out for within a single span of a bridge, means from one pier to the pier we can have the locations where we can install the sensors. We will be having accelerometers, strain gauges, tilt meters, and these type of things. On the top of it, we will also have the acoustic sensors, which can give you the ideas of different types of cracking coming out. Then this is what we have, the system designed for collection of the data. Okay, we will have the nodes, and from there the data are going to come, and then that's all the things that is basically taken care by our colleagues from the computers and the electronic side. And these are the DAQ cards that have been developed inbuilt. These are not basically, we have tried to do things as much as possible as that we can over here. And for the initial cases, we have run it in the laboratory, and successfully we are able to use these DAQ cards to collect the data. And some of the things were also shown in the first video that we showed in the beginning. So up to the laboratory part, it's working fine. Now the next stage is to go to the real structures and then start collecting the data from there. In parallel, we have also worked on using the image processing and again employing the AI techniques to identify the cracks of different types. These are the databases which were used for different types of cracks, initially for learning. This is one data set. These are another types of data sets that we can encounter in concrete and in surface pavements and those type of things. And after having the learning things and all those type of things, so we do some, we take some pictures from this Samama bridge again, and then after processing, you can see this type of crack is basically can be predicted over here, because the other ones are very clearly differentiated, which part is cracked and which part is not cracked. And then we can also measure the widths and all those type of things from here. We are intending to develop a sort of app that can be given to the inspectors of bridges and all those type of things to, if they can go and just have some scanning so they can also get the things. This is another picture. This is the actual picture that was taken, and after processing, you can see it's very clear how the things are, and it's very clear, and we can clearly recognize the things that are happening. And with time, if we have the data with the time, we can compare the things, how the things are propagating and working. Now, this is just to show an example. This is the famous tower, the water tank tower in the NED. So this is from the LiDAR, the data collection. So this was very initial run. Then further collection, refined, and this is from the top. So we can have all the things from here. Then that can be transferred to the to the VR environment, and there we can just work out with the things. And this is just one example. When you bring it in the VR environment, you can just go immersive and have the things and work out the things. Okay? So that's what we have done up till now. So the only thing that we are left over here is to collect the data from the real structure that we will want to look at on the CPAC routes, and then come up with the final decision-making tool. So that's what we have achieved up till now, and we hope we will be able to do the remaining things, and we will be able to successfully come up with a product that can help in the decision-making of the maintenance and the repair and rehabilitation and all those type of things within the Pakistan environment. So I think that's all from my side. So that's what we have achieved now, and based on that, definitely we thought it's time to share the things with the with the industry existing in Pakistan, so that they can become aware of what we are doing, and then we can look for the other things. So thank you for your patient listening.
Thank you, Dr. Asad. Now we have our second presentation, titled IoT Integration into Structural Health Monitoring of Civil Infrastructure, from Professor Dr. Saad Ahmed Qazi. Unfortunately, he is engaged in some parallel event going on. So we have the presentation will be done by Dr. Hasher. Please, Dr. Hasher, come on stage to deliver the presentation.
Assalamu alaikum. By the way, it's not doctor, it's just Hasher. So thank you for the wonderful introduction, and welcome everybody. And so I'll try to keep my presentation to the point and concise. So what I'd like to discuss in today's presentation is the use of IoT, the Internet of Things platform, in the structural health monitoring part. So let me begin with the very beginning, a very brief introduction of what IoT really is. So this is a bookish definition of IoT, which describes devices with sensors, processing ability, and software infrastructure that brings everything that is non-living, that brings everything to life. So all the things that we see, usually sending data, processing that data, and running predictions, is basically IoT. So if we consider AI to be the brain of today's computation, IoT can be considered the hands and legs, or the actuators of it. So it's the whole IoT infrastructure is actually a very crucial part of the AI era, I would say. We can clearly see in the picture, and we have been seeing actually in our daily lives how IoT has been helpful and is being used in different architectures, different systems, smart homes, whether it be Alexa, whether it be Google Assistant, whether it be different monitoring solutions. A lot of them, we know a lot of them, and they all are basically IoT. If I'd like to describe IoT in a very brief and a non-technical manner, it would be giving life to the non-living stuff so that it can communicate or send data. So a typical IoT infrastructure basically comprises of these four things. A data acquisition section, a data transmission section, a data processing section, and data visualization. And these exactly are the three parts of the CPEC CRG project as far as the IoT infrastructure is concerned. So the data acquisition system is where all the hardware complexity lies, basically. So since you have to collect data from a bridge, it's not I would say a very easy task. Since you are not very much sure about the power requirements, you have to place all of the sensors in a very rugged environment, and you have to collect data from there. So it's quite a challenging task. I'll discuss it further as well. So usually in all of the IoT systems, the first step is data acquisition. When you get the data, you send the raw data to a server, to internet, to a computing platform where some computation, some calculation can be performed, some AI can be run on their data, or any analysis can be done. So that's the next part, which is data transmission part. It's especially a challenge in, again, remote locations, as far as using IoT systems like Alexa or Google I/O or things like that are concerned in indoor environment. Data transmission is usually not a very big concern, because you can simply connect your system, your device, to a local Wi-Fi, and then you can just get access to the internet. But when you're using the device, or when you have certain requirements of using your data acquisition systems in remote locations, it actually becomes a challenge. So you need to have coverage. For example, since there are sensors placed along the bridge, you need to have whole coverage, so that you can send data from all sensors right from the beginning of the bridge to the end of the bridge. And it's very important to then send whole of the data with, of course, certain speed, certain accuracy, and of course, keeping everything within a certain cost. The next part, I would say, is data processing, and it's actually the brain, and it's where the magic comes in. It's the AI part. So all of the data that is gathered and transmitted is actually uploaded to a cloud server, and then the data is processed using AI or any other technique. Then, of course, once the data is processed, you can either visualize the raw data, you can visualize different trends, different graphs, and also you can visualize, or you can use the AI outputs, the AI predictions that have been done. So this is a typical architecture. I'll come back to the architecture of CPEC as well. But yeah, if that's a typical architecture, what the part of data acquisition system is the IoT circuit. So the IoT circuit, this is the actual hardware that we plan to use. Of course, there will be developments, there will be improvements in this. But on your left is the main IoT brain, right? It processes all the local information. And on your right is the whole circuit, which actually uses, as if you see on the circuit on the right, you can see this left circuit right over there. So the circuit is a microcontroller on the left, and of course it has all the processing power, it has the decision power. Now you have to interface different circuits or different sensors with it. Once you interface those sensors, and once you do all those communications, so what it does is it basically gathers all the data from different sensors, and it's very important to then process it. And I don't mean exact AI kind of processing, but a very rough kind of processing on the ground and on the situation where this data is being gathered. So the data gathers from all the sensors. This circuit does it. We are using an ESP8266 microcontroller, which is an off-the-shelf microcontroller from Espressif, a Chinese microcontroller manufacturer. And it's an impressive piece of technology, I would say. It has Bluetooth capability, it has Wi-Fi capability, and a lot of these things. So then, as you can see in the diagram as well, then you can collect the data, and then you have to transmit it to some node. There needs to be a master-slave kind of communication, because you are collecting data from a lot of different points. Then you need to gather all of that data into a single point so that you can send it to server. Of course, there are different techniques to do that. The IoT sensors that we are using are these ones. Of course, there can be changes. There can be updates to these, but these are the ones. For example, let's start with the acoustic emission sensor. It measures the acoustic emissions and gathers its data. And then we have the SST20 temperature and humidity sensor. Again, it's a precise sensor that measures the temperature and humidity, and it's again very important for the structural health monitoring. The third sensor that we're using is a strain gauge sensor. And in the picture on the center of the page, you can see the placement of different sensors, how they will be placed. The strain gauge sensor is basically used to measure the strain or the pressure that has been put on the structure. So the shape of the structure, how that shape or how that structure is being affected by any kind of load that comes onto it is actually being measured by strain gauge. The final piece of sensor is 9-axis high precision tilt and vibration sensor. So this is again quite a good sensor that measures vibration as well as tilt. So of course it measures vibration, as is clear. It also measures the angle, the tilt at which it has been placed. So if any car or any object passes or anything happens to the structure, you can actually measure what difference in the tilt it has produced. And of course it's a high precision sensor, of course, because you are not placing it on a quadcopter or a car or something that is going to actually rotate. It's not going to rotate, of course, but you have to measure high precision data with it, since it's actually placed on a structure. So these are the sensors that will be used. And again, coming back to this slide again, then you can see that all of those sensors are actually part of the data acquisition side. And you can see that there will be multiple data acquisition cards on the top section. And they will be placed on ground on different places, on different parts of the bridge. They will gather the data from sensors, as we have seen. Then those data acquisition cards will actually communicate with each other over either a wired or a wireless interface and send data to the server. Again, we can see the correlation, the data transmission part. Then it's sent to the cloud and the visualization. So coming towards visualization part, this is a very raw data visualization. We are gathering the data. This is some testing data. The timestamp is there, x-axis, y-axis, z-axis vibrations are there. Angles are there, x, y, and z. Again, these are tilt angles. Strain readings from strain gauge are there, temperature and humidity are there. These are the raw data before any kind of processing. And once you process it, again, this is still unprocessed data, but you can, of course, plot different graphs. And basically, this is where you can see the beauty of data by having the dashboarding. We have seen the dashboarding well enough during COVID times. Of course, it presents you a whole good picture of the raw data, because the data is not useful without it. So you can have live charts that are being updated by the live data coming in. You can have different average values. So the kind of way it can work possibly is by having a micro level data, then a macro level data, a type of data where you can monitor the whole CPEC thing all at once. What's the average values? How are they changing? Then you can, of course, see individually how individually each bridge is performing, how they are changing, how they are behaving, and things like that. So this is how the whole thing has been working, and now moving forward, we'll be integrating AI parts into that and improving the accuracy, building the whole system, and deploying it would actually, I would say, be a great challenge when we go to actual different sites. So that's it from my side. Thank you so much.
Thank you, Muhammad Hashir. Now we will take a break for Maghrib prayers. We will gather after 10 minutes. You can offer namaz at civil department or at the mosque. Thank you. international experience. I would like to request Dr. Farooq Arif to please come on stage and moderate the session.
Bismillahirrahmanirrahim. Thank you, Laiba. I welcome you all once again to this session. We have a panel discussion regarding challenges in civil infrastructure development management in Pakistan, issues and learning from experiences. We have a very good panel for today. I'd like to request the panelists to come forward and join us on stage. First of all, I would like to request Dr. Naveed Anwar, our keynote speaker for today as well. Please, sir, join us on the stage. We have distinguished guest with us, Sayyid Salahuddin Ahmed, who is the Managing Director and CEO of Karachi Water and Sewerage Corporation. Sir, and proud NED alumnus as well. Sir, please join us on the stage. I'd like to request Mr. Ghulam Mushtaba Sheikh, Regional Director of AI Engineers. Sir, please, if you can also join us on the stage. Dr. Abdul Jabbar Sanghi, Chairperson, Department of Civil Engineering. And finally, Professor Dr. Raza Ali Khan, the Chairperson, Department of Economics and Management Sciences. Thank you very much. So thank you very much all the panelists who have joined us at this hour for the panel discussion. I'll request you to please take your opportunity. I'll not identify with any question who would like to answer. So I'll keep the floor open. Anyone of you would like to answer the questions, that will be great. The purpose of the panel discussion is to highlight the issues and challenges and how to overcome and we have a good mix, including the representation for infrastructure management organization, the technology company from our industry, such as AI engineers. We do have our keynote speaker, Dr. Naveed Anwar, from whose international experience we'll gain. Dr. Azali Khan, being yes, he's the chairperson, but more so we have invited him in his capacity as the one of the finest economists we know, at least in the province of Sindh and even in Pakistan, and being my teacher for so many times as well. And Dr. Abdul Jabbar Sanghi, not because he's my boss, but because he has been involved in a number of infrastructure projects. They are forensic, and we'll gain from his experience, specifically with relates to what Dr. Naveed Anwar also discussed. So let me put forward a question. First of all, very simple and easy, because my job is easy, right? So what do you think, in your capacities as different experts, or what do you perceive that there are challenges in infrastructure development? Specifically, I'm not talking about management at the moment, but infrastructure development when it comes to countries, developing countries like Pakistan. So if any one of you would like to first answer, maybe Salahuddin Saab, you can start.
Okay, I can. Okay, since I'm holding the mic right now. So it's fine enough. Thank you very much for actually inviting me here. Right now, as you know, just been introduced that I've been working as the Managing Director and CEO of the Karachi Water and Sewerage Corporation. Just to give you an idea, Karachi Water and Sewerage Corporation has an infrastructure of about 12,000 kilometers line that has been laid over a period of time for the last 100 years in Karachi. And when I say this, there are a number of challenges that have been attached with the infrastructure development as far as the KWNSC is concerned. I see that So there are some capital expenditures. There are always that needs to be followed through a repair and maintenance. But unfortunately, what I have seen here in KWNSC also, first, when I look towards the development side, we heavily depend upon the provincial government's intervention. And so the utility itself has to either make money through their own assets, or we have to devise a solution whereby a continuous exercise that needs to be done, through which, okay, fine, there has to be an addition of the capital investment into it, but whatever infrastructure is there, probably we need to set aside a complete 1 year for the repair and maintenance for the annual development program for the interval of about 4 years or so. Because what I have seen that our infrastructure has been dilapidated over a period of time because of the lack of maintenance. And the reason being, today we are discharging, for instance, 300 million gallons daily into the sea because of the reason that our sewage treatment plants are working at the suboptimal level. We couldn't able to catch up the pace, including the maintenance that was actually required vis-a-vis the pump maintenance or the other maintenance related to the infrastructure. I'll just short in terms of my perception as to how the infrastructure maintenance or development should take place, that we should not rely on the breakdown maintenance, but we should actually working on an environment whereby this maintenance facility should be added on with the capital expenditure, so that, and it should be spanned for the next 5 to 10 years, depending upon the nature of asset that you are adding in, so that you should be able to actually save that infrastructure from the breakdown maintenance rather than a regular maintenance. This is my take on this. I think anybody else can jump in. Thank you.
Before I'll request Dr. Raza, because one key word that Salahuddin Saab has used is asset. And I think asset management is something which is missing. I am myself witness to the huge infrastructure of Water and Sewerage Board, lately known as, and you believe me, the way or the ease with which you just turn on your tap and the water flows out of it, if you see that infrastructure, all the treatment plants, the Dhabeji pumping complex, and all the filtration plants, you would be amazed at the level of infrastructure and the need and the intensity that they have to put every day. So it's easy to just view a news and say everything about what you do not know. But still, I think, sir, asset management, specifically from finance and investment decision making, is something which I think is missing, right?
Yes, you are absolutely right. But I would like to begin with your first question, is that what are the main challenges? And I think that from my perspective, in the context of civil infrastructure projects and management in Pakistan, numerous basically challenges that is basically we face in our daily life. The first and important challenge is rapid urbanization, and with the population growth, right? Which is basically putting a lot of pressures on our existing as infrastructures. Then we have an inadequate investment, right? And we have a constraint of the finance. Obviously, basically, we have a limited finance resources, so hinder the development of new project as well as the maintenance of the existing infrastructure, right? And third, I think that the next problem is political, basically, instability as well as the bureaucratic inefficiencies can hamper the that timely completion of the project, leading to the delays and cost overruns, right? And fourthly, unfortunately, we have a basically victim of the climate change also. And that's why basically we have a problem this side also, which basically adding the layer of new complexities for the Pakistani structures, right? And lastly, you can say that the issues of the corruptions and lack of transparencies can basically hamper the situation. But I feel that over and above that, the most significant challenge is human resource capacity. Human resource capacity, unfortunately, Pakistan human capital outcome is lag well behind the rest of the South Asian countries. And you know that inefficient human capital and suboptimal utilization of the human capital basically is the major constraint in infrastructure development. So I think that these are the things which we have to consider for improving the systems. And then if we basically talk about the World Bank report recently, basically, which I saw the report, and in which they mentioned that the 40% of our children under the age of 5 are stunted. And 21 million basically school-going children are out of school. And 79% of 10-year child are unable to read and understand the basic text. And you know that what is our budget of position? We allocate only 2.2% to 2.5% of our GDP on our education sector. 0.9% allocate for the health sector. So, वो जो एक गालिब साहब ने कहा था ना कि कर्ज की पीते थे मैं और समझते थे रंग लाएगी हमारी फाका मस्ती एक दिन. तो under these circumstances and with these situations, I feel that कभी भी हमारी फाका मस्ती रंग नहीं लाएगी. We will have to think. We will have to basically make the comprehensive reforms in our education sector, in health sector, as well as workforce development. We will have to basically produce the good skill set. Until unless we will not produce this type of people, in the basically your Dr. presentation, you can see that कि दुनिया कहाँ जा रही है, technology. And we need to invest on the technology.
Sir, Dr. Sanghi, taking this lead from Dr. Raza, you can start with the initial question as what do you see challenges, but specifically because I know you being a very structural engineer for a very long time, but in your capacity as being representative of the academy as well, what do you think are the challenges when the human resource, which we are actually producing, right? When they come in, what sort of challenges do we face from what Dr. Raza said, and then how we are trying to basically augment that to come up with good human resource, if you can shed light on both.
Thank you very much. I think Dr. Raza Ali Khan Sahab has very rightly summarized one of the all the major challenges that as a country and as a society that we are facing. And I agree with him. The core challenge that he has identified is the human resource. The lack of capacity these days, or even if we have a good quality human resource, we tend to lose it to the brain drain for a number of reasons. Of course, they would have better economic opportunities abroad, so they end up going abroad. But nevertheless, I think as a representative of one of the oldest university offering a civil engineering degree for well over 100 years, I think we need to design our programs, and some of this we are already doing. We need to design our programs which prepare our graduates for the challenges that we are facing. So the kind of projects that the graduates have to deal with, the requirements of sustainable development, these should be the core elements in our curriculum. And we have been upgrading our curriculum, continuously improving our curriculum, that whatever projects that we plan and execute, those should be, should have the core requirements of a sustainable development. And once we are able to produce the human capital, who of course needs to be incentivized and attracted so that they are able to stay and spend a bit longer within this country, and with the right kind of budgetary allocations and the project planning and execution being done in an integrated manner, I think we'll be able to produce an infrastructure which should be able to last. I should not put a year, as Dr. Naveed said, 50 years or 100 years, but we should be able to at least produce infrastructure where the life can be extended. And I think I agree with my dear friend Salahuddin Saab as well, that when we are planning these projects, primarily we are allocating the capital budget, the development budget. There is no component in terms of the recurring component for maintenance, and that ends up, once usually we get to the breakdown stage, that then you have to sort of allocate a huge chunk of the budget. So as part of the planning exercise in our initial proposals, if we have the projects where the development component carries some form of routine maintenance component, that would help us extend the life of our projects and the infrastructure.
Sir, just on a lighter note, with the number of years thing, actually many of you, I see my students, Europe fought for 200 years. They remain in dark ages. I don't know why we get so sometimes pessimistic. We are just a baby nation. 75 years is like a young 16-year-old boy when it comes to infighting and all. And Europe then learned that there is no need to fight with each other. Let's take that fight somewhere else. And they took it through technology somewhere else, right? But taking the lead, I still think that we do have talented human resource. We do lack in, as Dr. Sanghi said, in sustainability of that and durability of that, because most of younger generation now want to work abroad maybe and big things, and they sometimes forget, but they do return back, right? By that time it's late. But then sometimes what they go outside for might be brought here, and that has been the case with AI engineers, right? I'm not marketing your company, but I'm trying to suggest that AI engineers have worked for a number of years outside, and then they thought that we should respond to these requirements in Pakistan as well. Can you shed some light, Mujtaba, on as to how and what sort of areas you have been, without marketing of course in a subtle way, that like representing the construction companies or maybe technology companies, how have industry responded to these challenges, or is industry really responding to these kind of challenges?
Thank you, Dr. Saab, first of all, for having me. I think I'll have my share tomorrow to market my company also. I know. So that being aside, first of all, Dr. Saab said, and he's my humble teacher, as a nation, we are not a maintenance kind of people. So if we even start with ourselves and look at how much we maintain our appliances at home or our vehicles to say, I mean, some of you might love their vehicles, so those being aside. But I think as a nation, we are not built and maintain kind of people. We are built, replace, and built again. So that's the kind of way we work. But I think as AI engineers have worked abroad, I myself worked abroad. I have seen life cycle analysis, and Dr. Sanghi was mentioning about it. Even if you look at the public procurement guidelines, they call for a project to be selected and finalized on the basis of life cycle analysis. And hardly I see my clients that actually run this at the time of selection of projects. Usually the CapEx is what is basically governs the project decisions. And so lack of funding is definitely the cause, major cause. As a developing nation, we don't have that kind of funds to look 30, 50 years. But I think I'm seeing some difference in the industry, and I'm going to pick two examples. One from private sector, where facility management is coming big time. So some of our clients are actually asking us, do we provide facility management services and go beyond handing over the buildings? Some of the recent incidents, most of them actually in Karachi, in private sector buildings from fires and other hazards, has actually dictated those. So some of our clients are now demanding that as you design our buildings, there has to be a life cycle time safety analysis, OPEX analysis, so that's what is changing. And on the government sector, you have the speaker as the CEO of KWSP. We are helping with, our government portfolio is less, but I realize that in some of the PPP projects that we are doing, I mean, they have a wonderful maintenance strategy. Now, you are handing over to a private developer, but I think the government plus private, where the best of both of them come together. So, for example, I have been involved in a mass transit 30-year PPP feasibility last year, couple of recreational parks. So now they dictate that the facility has to be maintained for at least 30 years. 25 to 30 years is generally the cycle. And I think NHA started this with their motorways, and you can see them, and they have been reasonably maintained better than some of the other infrastructure. So I think the more this alternate delivery, the BOT concept, the PPP concept come, some of the large public sector infrastructure also will be maintained, at least for the first 30 years for sure. And hopefully that will actually enable that human capacity development that we are talking. So let's say if the government sector or the team, the mass transit project I'm talking about, there was a 30-year training program, the capacity development program, and then the developer phases out. So I believe that will be addressed. So we must see more public-private partnership delivery model in the large infrastructure projects.
That's interesting. Dr. Naveed, if may I ask you, and you would have a different perspective, right? You have heard of the challenges and issues kind of that we probably are facing. Some of them may be much more, some of them people may have different opinion. How do you see when you compare these challenges with the rest of the world, specifically developing countries? Are they the true challenges? I will talk about the solutions later, but do you see that these are some kind of things that are very normal and normally have been faced by developing countries, or we are much into deeper holes?
Yeah, see, the thing is that it's so varied. Because let's just take a few examples of countries of this part of the world, not crossing on the north side, on the west side. So because most of the time that I have been involved with the ATB and World Bank projects as the team to review their projects for about 11 countries. So I have had the opportunity to visit infrastructure projects in China and Laos and Philippines and many countries, yeah, as an evaluator when the project is finished. And so my job has been basically to identify what is the problem in those projects and their funded projects from World Bank or ADB. And there are three problems that we have identified consistently in almost in all of these countries. The first one being the same, that the project has allocated enough funds for construction, no funds for operation, even for small things. And I can tell you two very interesting incidents. So there was one project that I went to evaluate, and it was providing water supply to villages from water stream. So there were two villages, and so I went to inspect, and then I found that one village is getting the water. The second village is not. This village is supposed to get the water, and there's no water. The piping has been installed for almost a year. So and so went there and we invested, and the water is being taken from the stream and it's running through, but nobody's getting the water. So we found that the water is simply going through the pipes to the next project, and this project did not have the budget to put the stoppers or whatever. So the whole project is not being properly benefiting people because of the improper implementation of small details by the local department. So this is consistently a problem in many countries, that funded projects not implemented by the PMUs.
Delegation is an issue.
Yeah, so that and then big projects become ineffective. Second one is the same problem, that they have the funding to make it, but they don't have the funding to maintain it. So after the project is finished, then there won't be anything. But there are some really good examples. Thailand is probably the best in this whole region in terms of the infrastructure project. The best roads, the best bridges, the best everything. Hardly any issues with the infrastructure projects. And one of the key reasons is what you mentioned exactly, is most of their projects are PPP, or basically based on this BOT concept, most of them. So they are well maintained, they are well taken care of, and they have the whole system running. So I think ultimately, because somebody has to have the interest to do this, financial interest to do this, if we create that, then it will work.
Actually, that's true. And not that my experience is, I've been it's in front of all of you, although it looks like that I have taught Dr. Sanghi 4 courses in undergrad, but actually it's vice versa. But let me give you an interesting comparison. Fortunately, I've been blessed to work on a number of infrastructure projects. I've never been to a developing country other than Pakistan, right? All of the countries I've visited have been developed countries. So I can give you a different perspective. And all the time, I've never been there for the sake of tourism. And I know how much this statement would make my wife hate me. But I've always been there for some work. And working in US and even with some clients in Turkey, I'll say that they have different kind of challenges. I mean, what we are discussing today is mostly related to, yes, the investment part of it, but then other than that, the condition is our prime concern. They don't have anything left with regards to condition. They have a good database and everything. The problem with them is how to spend that money justifiably, because they are answerable to each and every penny they spend. And that led me to do my PhD in that area. When I saw, for some of you who may not know, for example, American Society of Civil Engineers every year publishes an infrastructure report card based on number of parameters, just like you get your transcripts, just like you get grading for your infrastructure. And that is for each and every state, each and every county and district. So I happened to read that and realize that how they are doing grading. I said that is some kind of a, I'm sorry to use the word, but fake work that we do just for marketing purpose. Then I realized, no, it was a big database behind that. And that is where I started working. The first time I sat with my committee and the one of the bridge engineers said, what the hell is it talking about? Because he said, a bridge is about to fall and you are saying that you need to look into social aspects. I said, no, it's not about to fall. It will fall down when it has sufficiency issues. It's not fall down when it has use issues. I mean, spending money on a roadway, on a 6-lane highway, which is being used by only 1,000 cars, and a roadway which is used daily by, say, 5,000 cars, where should we spend money? I'm not saying that you leave behind that thing, but you have to spend considering the social aspect. People started calling me socialist, Dr. Raza. You say, your PhD is socialist. I say, it's not socialist. It is an integration. I think that may take another 75 years for us, but maybe the route to address these challenges is the other way around. I mean, we have worked around with the condition thing, and we have little bit failed, right, to maintain the condition. But maybe we need to start imposing certain constraints with regards to where the money is being spent. And that has to be done, as Dr. Naveed said, not at the level of maybe 14,000 feet somewhere in Islamabad. I'm not being critical, but like, for example, even if we have to do something, it has to be approved by ECNEC, right? We know, and they look at it from economist perspective. They don't look at from civil engineering perspective. They do not look at from the development perspective. They need to look into, they haven't gone to those areas sometimes where they need to spend money. So how can you spend money justifiably? But having said that, let's bring back the discussion to how to solve these things. How to solve, what are your maybe 2 cents each one of you in your areas. For example, if Salahuddin Saab can shed the light on the huge water and service infrastructure that we have, how to improve that and bring it to the world-class quality, specifically through technology, what sort of technology enabling that we may need to do that.
Okay, thank you very much. I mean, I think the discussion is now entering into a very interesting mode, because, you know, when I feel this, that there is a PPP efficiency which is coming in, and you talked about that. And on the other side, you say justification of entering into that project also. For instance, I just would like to quote an example of the Hub Canal right now. We have water 24 kilometers away from Hub Pumping Station. The reservoir is full. I cannot bring water because Hub Canal is in dilapidated condition. And it was built in 1981. And this was the task given to WABDA to have the regular maintenance. But some or the other couldn't manage. But now we are entering into a phase where we are going into a PPP project for the Hub Canal. Now, when they say, so we need to understand the EPC cost for an ATP project or a PPP project is same. Now, when I say this, the PPP project comes in and brings efficiency, the life cycle cost which talked about, and they also bring an accountability as to how we should maintain it and should report to the government. Now, when we say this, it is a big challenge for us to attract PPP in the water sector because of not that much of a credibility for the KWNSC to actually ask them to come in or join hands first. But now in the recent part it has improved. But what happened next is how you have to do it, particularly when you have to have a proper asset management system in place. When you talk about this, then you should have, starting from the inventory, and then coming on to their basic register with this, that how old it is, either the efficiency level has gone down, whether we have to replace or not. This decision has to be taken when you go minutely into details. We did the Dhabeji pumping complex audit. They have done everything except audit. So, so the problem lies here that, okay, fine, it's very easy to say to replace everything. Oh, no, it's not the required thing to do. So there are certain factors that we need to understand. So my understanding is, unless and until, and yes, we are very rightly so, if the client is not that capable enough to understand what is required of any project, we are not going to go through forward. Second, which is, I think it's a more important part, is there has to be a blend. As you talked about the technology, which is actually the industrial Internet of Things, which we talked about it. And I happen to be, I exposed myself to the way the meters are being built in Germany, went to Siemens company also recently. And I'm amazed to see this, that where are we right now? I mean, so you need to account for the basic accounting, as you talked about, that how they are being performing. That should become part and parcel of our internal practices. Otherwise, gone are those days where we would be spending a lot of money on the investment. But the point here is, let's stop adding on buildings rather than we should spend more on the maintenance side. My 2 points on this is that I believe we would be actually adding on khandars if this will continue. And we will certainly, because this has been the story of the past for the education sector, for the health sector, and no other sector is different than that. Thank you very much.
That's a very important point. Dr. Naveed, if you would like to say.
Yeah.
Same thing, right? What can we do?
Because now I've been away from Pakistan for a long time, so I'm not really familiar with Pakistan's landscape that much. But like I said, for most of the other countries that are going through similar, the first thing I completely agree is having the information to make decision is the good starting point. And most of the time that is missing right away. So now that we have these technologies coming up, the collection of information, transparency of the information, and having the ability to analyze the data and to make informed decision is the first starting point. At least we should know the condition, right? And which we did not previously. It was hard to find. But if we can now use the technology, whichever way. For example, simple one is that a lot of people are doing now is that they just say, okay, take a cell phone, take a picture and upload, and they try to use that information directly to have the condition reported. So that over the, if you analyze it over 1,000 people, 10,000 people over time, that alone becomes a huge data trove. If we can just use that images that people are uploading, complaining about something on the social media. So that, combined with IoT, combined with all the sensors, I think getting the GIS and all, so getting the information, knowing the problem is half the problem solved. So I think that would be my suggestion, to start collecting data and add transparency to the data that has been collected.
Exactly. And that data should also be like connected data, right?
Yes. So I think one thing that I often think is that if if the department person, whoever is looking after, knows that this problem, the CEO and even above the CEO can anytime take a look, go to the dashboard and take a look, it will be hard for them to hide anything. And that is, to me, is the easiest way to start fixing things, because, and it's already happening. People report this directly to the Prime Minister level and they start taking actions. So transparency and knowing the people who are responsible, if they know that this is no longer...
I just wanted to add, I mean, the lag of information actually flow. I think the basic root cause of corruption everywhere, in particularly the lack of information flow. I have recently started a control room, a monitoring room of the Hydrant Management Center, whereby I have tried to pass on this information to the general public that, look, we are actually issuing the e-receipts from the hydrants. Now you demand that e-receipt from the tankers that bring water to you. At the same time, I have actually identified that those are the areas from where they are actually giving you an example. These illegal hydrants I have demolished. I'm giving the credit to the entire team that they have demolished 250 illegal hydrants, which was like a taboo in the past. Now, what we did through the enabling technology, that we geofence those areas. If tomorrow, and we have actually installed trackers in on all tankers. So there are 3,000 tankers. We have the trackers installed. If they try to enter into that no-go area, and then there will be a siren.
And believe me, I know from my personal experiences as well as connections, you don't know how big service it would be if this thing goes successful for whole city of Karachi. And I think we should appreciate this this thing. At least it has been initiated, because this is the biggest problem. Remember, it is not good to say in front of the CEO, but if the water doesn't come through the hydrants, it will come into your pipelines. That is the simple equation. And by tracking, so I think ultimately that would happen, right? That is the technology.
So just to add on, it's before, by introducing this system, we were getting 6.5 crore rupees in a month. Today we are getting 16.5 crore in a month. Can you imagine the bulk flow meters coming from the technology? So I'm real-time basis on the last night. I mean, on the last light, I can actually say I have actually earned that much amount of money. Not in even discount. When I joined, it was it's not that I'm actually selling myself. 1.3 billion we were getting, and now today we are getting 1.7 billion in a month. So it will turn around things only because of the technology-enabled environment, and that is only possible when you put across this message clear that this is being led in by the technology led in.
Exactly.
Thank you.
Mustafa, would you like to add something?
Dr. Sahab, I think there's one more element, Joe. I think a lot has been spoken already. Like, one more thing that we are seeing now is about materials also. And I think the recent economic crisis which came, the best thing that has come out from Pakistan is we have clients who are dictating not to put imported materials or high maintenance materials. I mean, even those who wanted luxury tiles imported, they are changing.
So import ban was a blessing in disguise as well.
I must say. I mean, a lot of our clients are demanding not to put international imported products because of the time it is taken, and then the maintenance and the replacement will cost much more. So I think one other element is that as we develop these projects, we work on more low maintenance, sustainable products. I think a lot has been, there was an ASHRAE conference last week, and there was a panel discussion which was exactly about alternates to imported equipment and machinery in Pakistan, and a lot of manufacturers were there, and I was happy to see that they are stepping up and producing and manufacturing some items which were not even thought of before in Pakistan. So I think we should look at that. So the less we have low maintenance elements, the impact on the cost burden will reduce, and definitely the accountability and technology has already been spoken of. So I think that's the way forward also, something that adds value.
Dr. Sanghi,
I think a lot has already been said, and we're talking about the technology interventions using indigenous materials and all. But I think one core element is, since I represent academia, and we produce graduates who are going to work in the industry as professionals. So how they conduct themselves in the profession.
Exactly.
Professional practice, the ethical practices, the leadership, of course, that they are going to provide in future, that depends upon their conduct themselves. So if we are able to produce ethically proficient and honest professionals, of course, their education, the required knowledge and skills should be at par with the required standards, but at the same time, how they conduct themselves in the profession with the professional integrity and honesty, then I think we can sort of overcome these challenges, because everybody talks about the corruption, etc., and people would find ways and means to overcome the technology interventions and everything until and unless their intentions are clear. So I think this is one core element which we are trying to address through our curriculum and through our teaching and practice, that we improve the conduct of our graduates, we instill the professional ethics into them. I think that's one core area as well.
And that's true, right? We are OB accredited, right? So it means that if not 100% practice, but at least 90% we are giving is an education of international standard. But when it comes to practice, at the end of the day, it's your behavior. Right? I was talking to one of the students group, and we were talking about smart buildings. I said there are two types of smart buildings. One is user controlled. The other one is a smart on its own. The user control a smart building, I hope Pakistan, if we implement in Pakistan, it will remain the same case. Because if I would be controlling it through my cell phone, then I'll be doing the same habit, right? But if it comes to automatic control, then it might change. But that stage should not have come. The stage should not have come for the same reasons as talked about by Dr. Sanghi. But I like you to also highlight a few additions to how we have integrated technological aspects to our curriculum in terms of infrastructure as well, specifically maybe the different kind of facilities.
I think in civil engineering especially, some time ago, we started a separate program in construction engineering, where there was a lot of focus on how we actually execute the projects. When we look at any engineering project, as engineer, we usually teach them how to design. And of course, that's the main requirement for an engineer. He should be able to design, and then we have the technologists and the technicians required to actually implement it and execute it. But the problem that we have here, in design, there are only limited jobs. 5%, 10% graduates start, end up doing design. The rest, 90% of the workforce is in execution. So how the projects are executed, the quality of the project is largely dependent on the execution as well. So that is where we have put in a lot of focus, and there are specific sort of courses which incorporate the use of technology in construction. Our final year projects have been focusing on integrating technology into construction, and of course in our teaching and research at the postgraduate level and beyond also, there have been technology-driven interventions. And of course, today we are sitting in this conference. This is just one of the examples of a project within, research project leading to this area. And in fact, one of the core research centers that you are heading, the Virtual Reality Center, has been doing a lot of work in the use of technology into teaching and practice. So as an academic institution and program, we are trying to incorporate technology into our teaching and practice, specifically in the context of civil and construction engineering.
Then we have building information modeling, and we're just conducting for Pakistan Engineering Council. We are graduating around 200 to 250 fresh engineers from all over Pakistan. All the expenses are being borne by PEC, and we are training them for BIM to become freelancers, to become capacitated. They have come from Lahore, Quetta, all of the parts of the Sindh. And other than that, we do have established, just taking liberty, our labs like durability lab. We have upgraded a few. We are about to launch. It's already launched, but we would have soon the launching of the PHWI water center, which is going to be state-of-the-art facility. We do have smart classrooms to integrate, and all these efforts actually are to capacitate the production of technology-enabled human resource. I kept Dr. Raza for last because there are two, वो कहते हैं उर्दू में सर दो फरमाइशें हैं. एक तो शेर गालिब के अलावा सुनाने, अपना सुनाए सर कोई at the end. But the other thing is that what I want you to give us, is there light at the end of the tunnel or not? Because I'm asking this question to you because you seem to be the most pessimistic one, right? You said it would never happen. So I waited for that, and I think I should bring out optimism from the same guy who was pessimistic at the start, right? So please.
Okay. If you will not make request for the shares, तब भी मैं शेयर सुनाता.
सर अब क्रेडिट मेरा है.
आपने मेरा मतलब काम आसान कर दिया है. वो कहते हैं कि ज़िंदगी से बड़ी सज़ा ही नहीं और जुर्म क्या है पता ही नहीं. इतने हिस्सों में बढ़ चुका हूँ मैं, मेरे हिस्से में कुछ बचा ही नहीं. So most of the things basically have already covered by the learned speakers. But I would like to say that in the last, that we need actually the collective, coordinated, collaborative efforts, right? Involving with the government, private sector, society, and the international partners also. So actually the Pakistan can progress, right, by this way. So we will have to basically come on a one page. This is not establishment page. We will have to come on a one page, right? Then we can survive and we can move to forward.
That is actually the spirit. Other than that one page part maybe, but sometimes too many people come on one page and the page get destroyed. So I don't know. But let's say we have to, let me use a better words. One day our English writing center guy came into where I used to study FIU, and I very certainly used the word that are something like, I forgot that but the word was that the concept has been presented in alignment with something. So maybe we need alignment, right? Yes. We need to be aligned together rather than being on one page, because difference of opinion is good, but the alignment of the objective is something that we need. With that, I'd like to thank all of our panelists, Mr. Salahuddin Saab, to spare time, Dr. Naveed, who have traveled from Thailand. He was the keynote, and I must appreciate his, he just came in last night just for this, and he'll be leaving in a couple of hours.
One thing I would like to add here, basically Salahuddin Saab basically discussing about the data, and Dr. Saab is talking about the data. They are absolutely right, because last year I did a project with the KWSB, Integrated Water Resource Management, all right? And believe me that the KWSB people will not provide me the data of their customers. Even they do not have the proper data of collecting money from the customers. Now, collection efficiency.
Now they are.
Okay. And believe me that the collection efficiency was less than 60%.
Sir,
on the basis of that data which provided me by the KWS.
शिकवाए ज़ुल्मत शब से तो कहीं बेहतर था. अपने हिस्से की शम्मा जलाते जाते. मैं जला रहा हूँ सर. मैं आज भी कह रहा हूँ कि सर हम अपने हिस्से की शम्मा जलाएंगे. मैं NED का क्योंकि तालिब इल्म रहा हूँ सर, तो मैं ये कहता हूँ कि तमाम NEDians जो यहाँ बैठे हैं, दे शुड बी डिटरमिन्ड. चेंज आपकी तरफ से आएगा. मैं जिस इदारे में आया हूँ, आई एम द फर्स्ट ड्रॉप ऑफ ड्यू इन दैट एरिया. मैं सिर्फ ये बता देना चाहता हूँ कि देखिए, सारे लोगों ने कहा कि सर नहीं होगा. किसी ने कहा सर मीटर हाइड्रेंट पे लग ही नहीं सकते, आज लगना शुरू हो रहे हैं. ऐसी बातें की जो होना शुरू होने. सो आप सब लोग जो बैठे हैं यहाँ पे, यंग इंजीनियर्स, हमारे होने वाले बडिंग इंजीनियर्स को मैं बता देना चाहता हूँ, एवरीथिंग इज़ पॉसिबल. सिर्फ ये है कि जैसे बात की इन्होंने कंडक्ट की, एटीट्यूड टुवर्ड्स लाइफ की, एवरीथिंग कैन बी चेंज. ये आपकी स्पेक्ट्रम की बात है. कैसे हर्डल्स क्यों ना आए, आपने खड़े होना है और खड़े होकर चेंज की बात करनी है. और I tell you, wherever you go, inshallah ta'ala, you will prove your worth. This institution has given me everything, the confidence, the competence. Wherever I go, I think we owe much about what we have done here in NIT University, and this will come a long way in your career, inshallah ta'ala. Thank you very much.
थैंक यू. एंड मुझे फ़ायदा ये है, इंग्लिश बोलना आसान होता है, असल में वी आर वेबकास्टिंग एज वेल, लेकिन मुझे फ़ायदा ये है कि मैंने रज़ा साहब से पढ़ा है, सांगी साहब से पढ़ा भी है, उनके साथ काम भी किया और अब भी मेरे बॉस हैं. मैं बार बार कहता हूँ, लगता नहीं है, लेकिन ये मैं आपको हल्फिया बता रहा हूँ कि मेरे सांगी साहब से पढ़ा है. मुश्तबा से बहुत पुरानी वाकफियत, लेकिन AI इंजीनियर्स के साथ भी काम किया है. डॉक्टर नवीद, although we haven't had an interaction, but have been witness to his performance-based design and all those things. और वाटर बोर्ड से सलाउद्दीन साहब से तो नहीं, लेकिन मेरे वालिद साहब कोई मेरे ख्याल 20-25 साल उधर काम किया. So I know in and out of what happens there. So I'm truly telling you that the thoughts provided by our panelists have been not just coming from their mind but from their heart and experience, and they are true thoughts. And I hope you have enjoyed this conversation. Next time, sir, अगर आपकी इजाज़त तो एक मुशायरा भी रखेंगे साथ में क्या ताकि तुर्की जो है वो, और टेक्निकल मुशायरा उसका नाम रखेंगे और बड़ा मज़ा आएगा. मेरे ख्याल से सिर्फ 2-3 शेर तो अभी आपके जहन में भी आ ही गए होंगे डॉक्टर असद के. तो विद दैट आई विल थैंक यू ऑल and for sparing time. Inshallah we would have some gathering like this, and before we go to the dinner, I'll request Dr. Asad, if sir please you can come forward for the award of shields to our panelists. First of all, I would like to request Professor Dr. Raza Ali Khan, sir, if you can please come forward. चेयर यहाँ से उठा दो, मेरे ख्याल यहाँ पे. Please give a big round of applause. I'll request Dr. Abdul Jabbar Sangi. So sir, please. सर ये बॉक्स से निकाल लें, सिर्फ बॉक्स से निकाल लें. ये फोटोग्राफर नहीं है आपका? नहीं वो वीडियो वाले कर, ये नहीं बैठी हुई फोटोग्राफर, हमारा फोटोग्राफर. And last but not the least, Mr. Salahuddin Saab, if you can please come and receive your. So thank you very much, sir, all of you. The audience, thank you very much for joining us for the session. Now we would proceed for the last but maybe one of the most important item of the day, and that's dinner. So I'll not be in between you and dinner. Please join us for the dinner at the fountain area. But before we leave tomorrow's session, I'll brief you about the tomorrow's session. We would have parallel sessions running, and 28 submitted and technical reviewed papers will be presented. Some of them online and most of them physically at 2 different halls. One of them is Ashraf Habibullah AV Hall, that is in the Department of Civil Engineering, and the other one is Mechanical AV Hall, which is just in the adjacent corridor. So our volunteers will be there to guide you. We'll start sharply at 9:30 a.m. And during those parallel sessions, as I said, 28 papers would be presented. You look at the program at the back of this conference sheet, and please select your interested areas and join us for the presentations. And then we would have closing session starting at 3:30 p.m. at the Ashraf Habibullah Hall, where all the registered participants and participant authors would be also awarded with the certificates, and we would have a keynote, international keynote as well from Dr. Emre Baraktar online. So please let's join us for the dinner and see you tomorrow as well. Thank you.